So this is example 1. Example 1, if we see here, we have angle, which is L angle, and we have skin and the flange. So the angle, if you see this angle, this one we call it flange. Okay, this one we call it flange. Okay, this is this one is horizontal flange. And the vertical one, this one we call it vertical flange. And this is angle L, because the shape is L, we call it L angle. And if we look at the radius here, so the radius here is generous, it's not sharp. So it's not sharp radius, it's generous radius. So if we have generous radius, so this section is formed. Means that it was made to the shape. If we have a sharp radius, the section was made, so this L angle was made from extrusion. So we see here the radius here is generous, it's large radius, and this is from mean. This L angle initiated as a flat plate, then they form it to make an L shape. So this is one of the method of construction of the aircraft. We have skin and we have angles. Angle can be extruded or can be formed. And the form section like this normally used for the lighter structure or secondary structure. For the primary structure which carry heavy load, and this angle will be extrusion. So for this situation, we may consider this angle as a stiffener or stringer, which is a thin section attached to the skin. So this is skin. So this horizontal flange having damage. So once you have damage, and damage has to remove. So in this case, we have horizontal damage, and to repair damage we remove. It's just like if you got sick and, for example, you may have part of your body having cancer or something, the doctor have to remove the part of the body. So it's a similar situation. Because the damage could grow. The damage may be from corrosion or from punctured or crack. It can grow if we don't remove. So we have to completely remove the damage. Once we remove the damage, we have to replace. So replace with the filler. Filler here is just to fill up the space, or inserts they call it. I use to call filler. Most of aircraft OEM call it filler, and for the Airbus they use this as inserts. So the why we need to use this insert is to fill up the gaps. Once you have removed this, you have the gaps. The gaps here, if you don't fill up with insert, the water, the moisture, or the sand or whatever residue will be collected under here, and that will cause corrosion. So we do not want anything to be collected somewhere in the structure, and the structure design requires that all those potential water moisture to be removed. So we do not want any water or moisture trapped in the structure because it can cause corrosion. So that's why we put this pillar. And then as we have lost this area, if we remove the whole horizontal flange, you already lost the whole section here. And then when you lost the section, as we have learned earlier, okay, stress is equal force or load over area. So if we lost the area will be reduced, will come down, become less. As radius become less, the stress will go up. So we do not want the stress to go up. Like yourself, you do not want to be stressed out. So tonight you may be stressed out because you're having the course with me. So I want to minimize the stress as minimum as possible by probably shorten the duration of the course of the class. So now when we have removed this section, we have lost area and the stress is become higher. Just take for example, if the force is 100 Newton, so it was 100 Newton before. Say the area is 10, so you have 10 Pascal. Okay? This is meter square. So if the angle, both angle, area, cross-sectional area. So the cross-sectional area here is 10. And now when we have lost the horizontal flange, the only remaining area is the vertical flange. So say this is 5. Okay. Now when we have 500 Newton over 5 meters square. So what do you get? You got 20 Pascal. So you see the point? As you got damage, it has to be removed. We can't leave it without it. We have to remove all the damage or the defect. You cut it off. You cut it off. The problem is you lost the area. You can see here. Initially, say that we have 10 meter square cross-sectional of the L angle. And you cut the horizontal flange. Now we left with 5. You lost half. You can see the stress go up twice. So as this one become low, this one will go high. So we can live with it. It's not acceptable. Okay. Increase in stress is not okay. It cause many things. It can cause failure, or it can reduce the structure. Remember, I have been explaining to you about the S-N curve, okay? In the previous lecture, we have this stress cycle and we have a curve, and if we increase the stress, the life will reduce. If we lower the stress, the life will live almost forever. So that is one of the problem, because reduce the such a life. Obviously, if the stress is very high, it will totally cut off the structure. It will make the structure fail. The structure will totally fail. So that is why we need to keep the stress low. How to keep the stress low? We have to put a doubler, or they call it splice plate. The splice plate will recover the loss. So if we put the splash plate, just imagine that you have whatever we have lost here, so we put it back. So we have recovered whatever we have lost. And you may argue we need this vertical flange. We only need to recover this. We need a vertical flange for you to be able to secure the angle, the splice plate to the angle, or else we have only floating uh, plate here. So in order for you to secure them on the plate, then we have to have another vertical flange, and together obviously you need the horizontal flange to replace the loss or area. So that's why we have this L angle replacement. Okay, any questions so far?
So means that after we cut the damaged part, we need to overlap the new flange.
Hmm.
Okay, sir.
Yeah, yeah, yes. Because why? Uh, it is like okay. Just imagine here. Okay, we have say a road, a road. So you're going through the road. You walk through nicely. Okay. Suddenly you cut it off in the middle. There's some maybe some piping burst or something. You have to do some work here. What do you do? That's why the construction, they will build a detour. So you can walk, use the detour road, and then continue your journey. So that is the analogy. Okay, can you accept that
Yes,
analogy?
sir. Yes, sir.
Okay, that's analogy. Okay, the engineering of it is, the engineering of this is, we have this plate and we have this plate. You only remove this area and you put a splice plate, and then you put say two fastener, two rivets. Okay. If we pull this plate, say 100 Newton, so the 100 Newton will be shared by these two. So what happened is, we have reaction force here 50 on the first, and then if you go up 50, this 50 will go up here, another reaction here 50. So equilibrium. So the next 50 will move to the next fastener, and then reacted by another 50. Through here we already have 100. And that 50 will be reacted through here and reacted down. So 50, this 50. And another remaining 50 on the next fastener. Okay, lay that down another 50. So you already have 100 here. So if you see here, what happened, this vehicle splash plate or doubler transfer the load from this to this side. So the use of this doubler is to transfer the load. Good. The structure and so that is a function of the doubler. So people ask why we use doubler? Doubler to transport the load. Why we need to transfer the load? Because now the part is damaged. We have no choice. You have to transfer the load across. As you cut, you need to cut off because you need to remove the damage. Because the damage may grow. The corrosion grow, the crack grow. We do not want those defects to grow. We do not want the corrosion and the cracks to grow. We cut it off. Then after we cut off, we lost the section. When we lost the section, the area become less. When the area become less, the stress is higher. Then you have to do something. So you have to transfer the load across. So to transfer a load across, it is a load, you need to transfer the load from here